Welcome back to our REG 468 and 368. This is our second subtopic on earthwork, which is on road ground improvement and reinforcement. In the e-learn, I have also included one reading article. So you can, I don't know whether you have gone through the article or not, but that article is related to slope stabilization, which is also part of what we call improvement and reinforcement. We want to ensure the profile is safe. So that article, I think, will give you some idea on what is the latest technique that we are using to ensure slope that we created is safe. Anyone would like to share what on the understanding of slope stabilization based on that reading? Remember last week I mentioned about slope, what they call the slope ratio of vertical and horizontal, 1 to 2, 1 to 1.5. You can see them also in that article about the need or the standard what they call slope that we require most of the time during cut and fill. When we prepare the embankment or we prepare the cut slope. So if you look at that article, you will see that the slope proposed was 1 to 1.5 for cut, which is similar to what I mentioned last week, which is actually the JKR standard requirement. But of course, even though it is a standard requirement, 1.5 to or 2, it also depends on because the stability of slope is actually depend on what type of soil you are handling. If the soil has got strong what they call shear strength, then that strength will be able to give you a steeper slope. And if it is the shear strength is less, then you need to have a little bit what they call it a longer slope. Then when it has a higher shear strength, so it depends on the shear strength of the soil. That's why we do what we call site investigation and soil testing to find out what is the shear strength of the soil. How do we determine the shear strength? There is one type of test. There are a few types, but the simplest one is what we call is a compression test that gives you you have a soil sample. You press them and then when it fails, that is the shear strength of the soil. And a more complicated test would be the triaxial, triaxial, XRAL, triaxial. Triaxial means you consider the three axis of the soil, the Y, X, and the Z axis of the soil, meaning it's a 3D kind of testing. So you will be able to get a supposedly better representation of the soil strength if you do triaxial test, but it will take some time. And the test is, of course, is more expensive and it will take more time to do that. But we have the machine in the lab to do that. Our lab has got a triaxial machine. If you like to try to do some soil testing to find what would be the shear strength using triaxial, then you can try the machine that we have in our lab. So that's about the slope that I think that was discussed in detail in the article that I have uploaded for you to read as part of your extra reading for this class. So today we'll be talking about road ground improvement and reinforcement. Okay, these are the issues why we need improvement and reinforcement, and or maybe sometimes modification of the soil. You know, if the soil is weak, you want to make it stronger. Just like us, you know, sometimes we feel weak, we minum kopi kuat sikit, contohnya lah kan. I don't know, I don't drink coffee or drink tea. So this is the situation when the soil gives way to what we call, in this case, it gives way. The actual reason in this case, give way is because there was a water movement below the soil. Actually, this site is beside a lake. Over on the left here is a lake. You see, so there is a water movement. There was a water movement from the higher ground here towards the lake. So what happened was the water take with them the soil particle below the ground. So when the soil try to adjust themselves because of some of the particles are gone, taken away by the water. So this is what happened. The soil adjusts themselves and it try to go into a more compact and dense condition because of there is a loading here. Because of this road, you know, there will be loading. When car move using the road, or a big vehicle like lorry, trailer, things like that, so the loading will cause the soil to adjust themselves, and when they adjust themselves, you know, there is a dimensional movement within the soil, and that causes this failure. So we want one reason why you want to strengthen or you want to reinforce or we want to improve the soil is to make sure the expected loading can be taken care by this road, especially the soil that is supporting the road. So this is one example where why we need the issue. Second, what you can see here is this is embankment. Embankment is you know, last week I mentioned about, you know, embankment is where you fill. You bring the soil from somewhere else and fill. In this case, it's an embankment made of mostly sand, because this is what they call land reclamation project. All right. This photo was sent to me by one of your seniors. She was in my class like this, and then when she went to work in Singapore, this is what happened to her project that she's handling. But you can see here is embankment failure. You see this line. There is a sliding. This portion of the reclamation is sliding to the left because of the failure of soil below the embankment to support the work done here. So that is another reason why we need to strengthen the soil before we can bring in this case, for example, fill material to create this platform. So they are creating this platform here, but then it gives way. And I mentioned last week, for filling work, if it's going to fail, you will fail straight away, like this case. You know, during the work, it will fail. For fill work, for filling, for cut, it will take some time. Months and years, depend on the type of soil that you are dealing with. So that's for cut. So you don't know when it's going to happen, if it's going to happen for cut area. Another issue is this kind of thing. You cannot even go into the site to do your work. You cannot go. How are you going to construct your road across this area if your machine cannot go in? I mean, if your machine cannot go in, you don't expect you're gonna hire a lot of labor to bring in by, for example, wheelbarrow or anything like that. So how are you going to solve this problem? So we need to strengthen the soil first before we can go in. So we don't want to see this kind of thing to happen. Even a higher ground like this, which is away from, you can say away from ponding or water or weak area, the failure still happen. This is the case of slope stability. You see, this is dropping here. The rock are dropping down because of the cut is too steep, right? This is what happened to cut area. This place may have been created earlier, maybe many years before, but the failure take place later. Like I mentioned just now, it will take time for it to fail. But to avoid this kind of thing to happen, we want to ensure we know how the slope is going to behave based on the soil type and based on the rock type, of course, in this case, from site investigation. So if we know it's going to happen, then we can reinforce it. There are many techniques to do that. Of course, later on we'll look at the techniques. You have heard as rock bolting, soil nailing, things like that. That's how we ensure that they are strengthened. Okay, even this is similar to what happened in the sea just now. Even on the hill, the sliding can still happen. If you're, in this case, especially, most likely, some of this portion here are filled, cut and filled, so that's what happened. It can still give way. So, how are we going to do that? How are we going to avoid this situation? One way is to strengthen this whole mess. That could be the possible solution. So again, this is the thing that we want to avoid. This is some of the solution that is in practice. For example, on top left here, you can see there is a white cloth covering this area. So this is actually a type of reinforcement. No, in this case it's a separator. To separate the weak soil down here and the good soil on top here. Alright? So this machine can start moving in little by little after they fill this area with the soil or sand. This approach has been used in one lake reclamation. I cannot remember where it is in Malaysia. Lake reclamation. A developer would like to fill up the lake. What do you call it? Used to be the lake. Now they have drained out the water, but still the soil is not very strong. It is swampy. So this approach has been used to cover the existing lake, and then a truck will deliver soil little by little and start covering the lake. Otherwise, the truck cannot even go into the site. So this is one approach. Second is, you can see this one again, another type of geotextile is used in this case as reinforcement. This is to separate the weak soil and the good soil. Now, you have this good soil. Just before you lay your road structure, you put another layer that will become what we call reinforcement. So this is how we reinforce this road foundation. So that later on, when a heavy vehicle pass through this area, similar to what happened in the first slide just now, it will not fail because there are reinforcement material inside the foundation. Just like we have reinforcement in this what we call column, steel reinforcement, soil can also be reinforced to strengthen its ability to support loading. Sometimes another type of solution is to provide what we call in this case is a strip kind of reinforcement, like in this case it is steel, metal strip. But of course you can also use a polymeric strip inside the soil. This is another approach. This is wrapping, you create this vertical wall by wrapping the soil little by little, and then you at every 300 mm thickness, and then you start going up, stacking it up, and then that will create a composite of you can say a bag that cover a big area of space to create this almost vertical like wall. This is, and then you can drive your car or lorry on top of this platform. So there is some common solution that is commonly used, similar to this one here, is the use of geotextile, similar to the one that we saw just now. This is the actual work in Kuala Selangor. In Kuala Selangor, jalan dia memang bumpy. Anyone from Selangor, you know that. So we need to separate the existing soil, which is weak, with the imported soil that we use as embed. Other method of ground improvement is what you can see on the screen now. Other than having, to insert something into the ground or to mix something into the ground, these are other types of improvement. One is, if the soil is weak, the ground is weak, how do we improve them? We replace them, right? Remove and replace. Second is what we call preloading. Preloading is like if the soil is weak, we train it to be stronger. How do we train to be stronger? We will before we start installing our building or road, we will ensure they are supporting certain load, and we call that preload. That's why we call that preloading. We give some exercise lah. You can say that lah. Bagi exercise, lama-lama jadi kuat lah. Macam you all lah. Siapa pergi gym semua ni kan. Angkat berat lah apa semua. Ataupun nak lawan lari dah pagi-pagi dah jogging 5 kilometer. So preloading. The third one is vertical drain. Vertical drain is slightly different mechanism, different working mechanism. Vertical drain is actually a drain that removes water from the soil. So when we remove water from the soil is supposed to become stronger. This is because if the water occupy the soil mass or the soil composite, it will not always be there. Sometimes, you know water, during the rain season it will be there, the dry season it will not be there. So whatever strength or whatever support by the water cannot be counted because it is not permanently in the soil. So the vertical drain will ensure, will take out all the water. Maybe not all, but certain amount of water that will give the soil sufficient strength to provide the intended support for the road in this case. Okay, so the vertical drain. So vertical drain will drain away water. In situ densification, I think just by the term in situ densification, you already understand. Meaning you try to make the soil into higher density on site, right? And the next one is grouting. Grouting is you mix the soil with certain binders so that they, instead of loose, they become stronger by having a better connection or better integration with each other. So that's what does grouting do. And also stabilization using admixtures, similar to grouting, but different material. For grouting, usually we use cementitious material. Stabilization, we will use chemical components to stabilize. And of course, last one is reinforcement, similar to what we have seen just now. Okay, more detail on what I call removal and replacement. I think I have explained just now. Maybe this is one of the oldest. But only limitation is this method is only practical above groundwater table. You know, if the very bad soil is below groundwater table, it is very hard, very difficult to remove it. You know, when it's underwater, it's very difficult to remove. It's only practical for soil above water table. So as soon as it reaches the water, then this method of removal and replacement is not efficient. That's why sometimes you see in the contract document, they call it unsuitable material to be removed from the site. Apa ada quantity there, certain quantities to be removed, and then you will be paid for that because you need to excavate, you need to have a transportation to bring and to dump somewhere that is approved by the authority. So you will get paid for removing what we call unsuitable material. But then, like I said, it is only practical until it reach water table. Once you reach the water table, this method cannot be used. You have to use other method. So that is why it is limited to in most situations. You know, we know that in most situations, the weak soil will be in the low-lying area, dekat paya, dekat low-lying area, and then most low-lying area will have water, right? So this approach may be limited to area that that is above water table. Preloading, I mentioned just now how you give some exercise to the soil. Preloading, we preload. So simply place a surcharge. Sometimes it's called surcharge. So if you come across a term in your contract document says surcharge, that's a preloading material. Okay, sometimes preloading, surcharge, those are the terms in construction work. Simply place a surcharge or additional loading, fill on top of the soil that require consolidation. Meaning when the soil consolidates, it becomes stronger. So that's the concept. So how to get them consolidated? We press them using loading. We put extra loading. So that's why you can see sometime along the highway or road under upgrading, there will always be embankment of sometime soil, sometimes even crusher run, big embankment of crusher run, but and a few months later you go and see it's no longer there. The crusher run or the soil is no longer there. It has been removed to somewhere else, right? And you may be wondering why was there before and suddenly it's not there. Orang curi ke tak? It's not there. It's supposed to be removed after you achieve the amount of consolidation or strength that you need. Surcharge fill are typically 10 to 25 feet. That is about 3 meter to 6-7 meters, right? Most effective in clay soil. So if the soil type is clay, so this method will be able to improve the soil tremendously because clay, the water content in clay is very hard to be removed. So this what we call preloading will help push away the water from the soil. And then once the water go away, they can consolidate. So this is what we call consolidation. Advantage, it requires very conventional earth moving equipment. You just need to bring the soil to the side, right? Any grading contractor, any earthwork contractor can do this. Dia ada satu bulldozer, ada satu jentera bawa tanah, then you level the thing and can perform the work. And this has long track record of success because it works. Only thing is that it will take time. You know, if you are the contractor, you are the owner of the building, you cannot wait. It will take time for it to let the soil consolidate. And also, the field must extend beyond the site. Say this is the site, this is my site. The field must go beyond the site to ensure that the soil under where I'm going to construct the building are properly consolidated. So it has to go beyond the site. And if you have problem with the boundary, like I mentioned just last week, with the law and things like that, you may not be able to do that. So it may not be possible at confined site. And the transportation of large quantities of soil to the site is required. You may have problem with the community, so and society with that lot of movement of soil, earth moving truck. And finally, surcharge or preloading must remain in place for months or years, and it delays construction. Usually, it will not be less than 6 months. So you cannot wait. The owner cannot wait. If you are a highway owner, you want to get the highway completed as soon as possible because you want to charge toll. 6 months will give you billion of ringgit if your road can be completed ahead of time, for example. So you don't want any time-consuming technique to do that. But of course, if you don't have any issue with the time factors, this is the cheapest and easiest method for you to use to strengthen or to improve the soil strength. Okay, this is usually what happens. What you see here is a cross section of land of soil below. Elevation 60 meter is supposedly your ground level where I am standing, and there is a sand with a thickness of in this case 9 meter, and below the sand there is clay, right? Clay another 6 meter clay, and of course down there is a hard layers of soil. What will happen is that once you have your highway up here, you need embankment, right? It will cause this clay, especially this clay layer, to settle, right? To settle in the long run, because clay will, like I mentioned before, it will take time for the clay to release whatever water inside the clay if there is a heavy loading on top of it. Not like sand can immediately adjust itself, but clay will take time. So what will happen, this road, in the long run, this road will start settle. There will be settlement. But the issue is not just the settlement, but the uneven settlement. That is annoying. If it's settled evenly like this floor, then okay, you don't feel when you drive. But the problem is different. Every 1 meter it has different rate of settlement, different amount of settlement. That is the issue, and that is what happened because it will definitely settle differently because the characteristic of soil composition over here at the next 1 meter definitely will be different. Not like concrete, it will be the same, right? This one the same, soil will be different. So that is why we need vertical drain. If you want to avoid the waiting time, then you will take this option. You add vertical drain into this technique. So vertical drain under the surcharge, just now you see the surcharge, vertical drain under the surcharge will accelerate or expedite the amount of water removal from that soil. So when you quickly remove the water, the soil itself can consolidate quickly. So that's the reason we are using vertical drain. And also, this drain can provide shorter way or path for water to flow and go away from the soil. All right? Time to drain clay layers can be reduced from years to a couple of months. So that will solve the problem. So that's how it looks like. See, just now remember we have preloading, and then we have this original soil. Without this vertical drain, this is a drain. When you press the soil, all water down here will have to go sideways. Go to the right and go to the left. But now you have many vertical drain. It has a very short distance to travel to the drain and quickly come out from through the drain. So that's how it accelerates or expedite the process. So this is soft ground. What you see here is quite a big drain. Originally, the vertical drain was actually a sand column that was in the 70s. So we use sand column. We push sand into the ground. Most of the time, we will drill a vertical. We will auger the soil and put sand in, and the sand become a drain. So when the water surrounding the drain will come out through the what we call vertical drain. But these days, this technology is no longer what they call it's obsolete. We don't use that technology anymore because we have more efficient way to do to carry out this technique. We use what we call PVD, prefabricated vertical drain, which is I showed you before. It is a material made of polymeric material that we push into the ground, and they are very small, 100 or 150 width in a roll. Come in a roll. I release the roll and push it to the ground. It will bring out the water from the ground, and then the construction can be also very fast because you just push into the ground rather than having to pour in sand and things like that. So things are a lot faster now. Everything is fast. You want even your internet, you want to be fast, so it has to be fast. I think we have seen this before. Prefabricated vertical drain. It's made of polymeric material, geosynthetic material, as substitute to sand. We don't use sand anymore. Installed by being pushed or vibrated into the ground. Most are about 100 or 2 mm. That's right. And thickness is about 5 mm. But water can go through. It can be a medium for water to come out from the soil. Similar illustration. Again, this is similar. We need a machine to push the drain into the ground. So this is what happened. Some description here. So without the vertical drain, the movement of water will take a longer path, but with the vertical drain, it can go sideways and then it come out through the drain faster. So that's how a vertical drain works to expedite the process. So this is for your information. Typically spaced 3 meter on center to center. In Malaysia, we have some of this, but now we have more vertical drain. All right. Next technique to improve the soil is again in situ densification. We try to increase the density of the soil. In this case, it is most effective in sand. Remember just now the vertical drain and the preloading is more effective in clay type of soil. But in sand, in situ densification is more effective. This technique utilizes mechanical energy or impact to increase the density of soil. So it can be dynamic and vibration impact or vibration to increase the density. This is the conventional way how we increase the density. We are all aware of this. You can see the compaction is done by this roller. You can see two different rollers, right? The roller on the right is for sandy type of soil. On the left here is, sheep-footed, we call it. But the other macam ni, dekat drum tu dia ada ni, macam we call it macam kaki biri-biri, that's why I call sheep-footed. So this is for clay type of soil. So different type of soil will be compacted in this case by different roller. That's why sometimes you see in your contract documentation, you need to provide the rate for these two different type of roller because and you use them at different situation. You don't use a smooth roller on clay soil, and you don't use sheep-footed on sandy soil. You must use it in the correct way. Right? So sand and clay. Right? Another technique is this vibration probe compaction. I'll just straight away show you the illustration better. So this is a vibration probe compaction. Probe means you something that goes into the ground. Probe. Right? Using a vibration technique to densify the sand in this case most of the time. Similarly, this is again the actual what they call the actual machine used for vibration probe compaction. Of course, these are some of the things that you need to include in your costing. If you do costing, how to what they call prevent excessive vibration and sound with, okay, to nearby building. That's why I mentioned if you are doing the work in Penang, definitely the earthwork by law requires all this precaution what they call system to be installed. This is similar to vibration probe compaction. It's just that it's a combination of vibration and water jet. You see, this is in Singapore again during reclamation. So land when you bring in soil as a reclamation material, it is in loose condition or pump or bring. Most of the time you pump from the ship or pump from the sea. So you need to compact them using this. In this case, is vibro flotation. This is how they are good for ground sandy type of soil. Not applicable for clay. You try to vibrate things in clay, you will get stuck inside there. Right? So you need to do the same. Okay, another type is just now vibro compaction. Now vibro replace. Alright, replace. This one This is in Jelutong. The already completed highway. Jelutong. Vibro replacement. In this case, you see this container here is containing a crusher run or crushed rock that is being pushed into the ground to replace, to occupy the soil below the ground, and it become a support. It can become like a column support. Even for building we can use this, but in this case it's for highway, road. So it looks like that. You start just now you have a container. You start releasing the rock into the ground, and you start compacting it using this machine, and then finally you can achieve what we call a profile like that contain, instead of a weak soil here, and then you have certain column of rocks. So that will be able to support your road and your buildings or your bridges, things like that. So these are the techniques used. Sometimes it can also be called stone column. Stone column, right? Stone column. Same thing, the similar site in Jelutong. So stone column, this is a stone column for the highway. So it will support the proposed embankment, right? So the embankment will be sitting on the column. It will not be sitting on the soft soil anymore. Of course, there are in this case there are two ways how to fit the stone into the ground. One is what we call top fit, and then another one is bottom fit. Again, for sand, we have another technique called dynamic compaction. In this case, basically what you do is just you release certain impact on the sand. In this case, use a special crane to lift 5 to 30 tons of block and release them onto the ground that you want to improve. In this case, mostly sandy type of ground. So that will compact the loose sand or the silty sand. So just as you can see in the picture, how they are compacted, right? And before that, you can see there is a marking here. So this thing is supposed to drop onto that mark. Okay, grouting, I mentioned just now. Grouting, right? You try to inject certain, what we call liquid or slurry material, which is called grout, into the ground. So you have cementitious grout or chemical grout that you pump into the ground. So for cementitious grout, this is an example. You have a machine that push cement and into the ground and create a cemented. You can create some kind of web inside the ground that is interconnected. When you have, of course, this is the first injection. The next one maybe is beside it, so it will create something like this, right? You have something like, and then it make the soil stronger. Of course, there are various type of grouting method. Just now it was grouting material method. The first one we call it compaction grouting. You start creating a bulb like this. Compaction grouting. Sorry. Compaction grouting. But then you can also create a column like that using jet grouting. Jet grouting, you release the nozzle will have a high pressure injection pressure from the pump. It will rotate, and then you provide a circular like spreading of the grout from the level that you want to start the grouting, and then it's moving up, and it creates something like this, like a pile, concrete pile, and that will support the in this case that probably is a better illustration of how it's done, the jet grouting, right? First, of course, you will drill opening into the ground, and then you start getting, and then the jet grout will create the column that you need to support whatever highway or building. Okay, last one is the admixture, meaning you mix the soil with certain kind of it can be cemented material like Portland cement, or it can be a chemical material. Meaning you have a machine that goes on the surface of the soil. You start mixing the soil using some mechanical what we call a machine that can release the cement or chemical into the soil, and then you mix them, and then you let them set, and it becomes stronger. Basically, you provide cementation. Okay, that is just now it was a various technique to improve the soil by having certain what I call interaction with the soil itself, right? But especially introducing new material. Another technique to strengthen the existing soil or the modified profile of the road is what we call slope stabilization. We need to stabilize the slope. I think you have seen this. Otherwise, something like this will happen. The slope has failed, and it brings down debris from the slope onto the highway, and then you cannot go back for your voting, right? Because the highway is blocked. Musim hujan ni. This is not South Highway. I think this happened before you were born. I think you were born after 1990. So this happened before 1990. This is, you know Goa Tempurong. Now we have divert the North-South Highway near Goa Tempurong. Now we have divert a little bit to the right here because there was it's too close. One is too close to the slope, and there was an accident where a vehicle was covered by this mud flow from this failure from Goa Tempurong. So we need a stable slope. Otherwise, that thing can happen. Especially like I mentioned before, if it's a cut slope, you don't know where it's going to fail. If you expect it to fail, make sure you stabilize it. So this is one way to stabilize the slope. So that's why this housing area that is nearby this hill area, the hill is being trimmed into this shape to provide what we call stable slope. Right? What would be the dimension? What would be the orientation of the slope? That is up to the engineers who design the slope. They have to study. They have to make decision based on fact and testing and data to provide this slope, so that will not fail. And of course, there is also what we call factor of safety. Most of the time, if you deal with soil, the factor of safety is 2, right? So you can say that, apa, hari ni banyak tanah pakai, aku kat rumah aku, okay ada macam tu, memang okay. You pakai factor of safety maybe 1. So you don't know, 50-50, mungkin fail, mungkin tak fail. So the factor of safety kita, when we do deal with soil, is usually at least 2. Factor of safety is 2. So if based on data, the slope is safe this way, then we make it even longer to ensure it's actually safe by a factor of safety of 2, because we don't know everything about the soil. We know only about the thing that we test, for example, that we take to the lab. And like I mentioned, the soil from one point to another point could be different. Maybe we test some soil here very strong, the next one is less strong. So that's why factor of safety of 2. Even that, we still see a lot of failure, right? Just like what we saw in the North-South Highway just now. Next one is the reinforcement of slope and embankment. Just now is how we try to stabilize the slope by modifying the orientation, the dimension of the slope. Now we try to even now reinforce them. Reinforce means we try to insert something or try to make them stronger by introducing external material into the soil or together with the soil. So we call that RS lah, reinforced soil. So you saw this just now before. We have a strip kind of thing that we put into the soil, have grid type of material that we make in the soil, that we place within the soil mass, or a sheet type, like cross sheet type, or rod, even a bar, like a steel bar, even in the soil, similar to what I put in the in concrete, or even fiber. Sometimes it's a fiber, cellular, and sometimes a wall itself, a network of wall that can provide this reinforcement. So reinforcement, soil, soil is stronger in compression than in tension, which is similar to concrete. So we need some material that is strong in tension to be inside the soils. Just like in concrete, we have steel, which material is stronger in tension. So to improve the strength in tension, geosynthetic is placed in soil for soil reinforcement. Most of the time, geosynthetic. Of course, you can put other things just now. Right? This is similar to I've shown before. You can create this almost steep wall earlier using geosynthetic within the soil, and of course you can have what we call vegetation spray on the surface later to make it look nicer. But originally it may look like this, right? So in this case, it's a combination of what we call soil nail geosynthetic wall. When it says soil nail, that means inside this wall, there's a nail that goes into the ground. A nail is usually made of steel bar that push it to the ground. And this nail also will be connected to this geosynthetic. Right? Strip material, you saw that just now, that we place inside the soil mass. In this case, a retaining wall. You can see many walls like this. This is inside the embankment. If you go to the top or behind this wall, you can see what we see many what we call segmental or precast wall that we see a lot along our highway or road in town. But they are being held back by this strip, right? And also it strengthens the soil and also holding the wall itself, so that the wall is stable, it doesn't collapse. So that is basically the inclusion of material inside the soil. Again, this is a reinforcement of slope and embankment. In this case, usually the soil on site itself is being reinforced. Just now, you are doing the construction, and for example, just now you see antu tadi kan kita bawa tanah datang and letak material. Tapi in this case, next one you see is the existing ground. Existing ground, how you are going to stabilize that? Let's say you have a slope. How you are going to stabilize the slope? You have existing soil. How are you going to strengthen the soil? So you will use this kind of reinforcement: soil nail, rock bolting, ground anchor, shotcrete, chemically stabilized jet grout. This is usually the technique to strengthen existing ground. So you see in this page, this is the installation of what we call soil nail. This work is actually not in Malaysia. It is in the United States. They are using this soil nail. They are using a machine that punch in the nail into the ground. You see, this is the existing road that has what I call failed. they are going to strengthen it. So they are using just what you call excavator machine, but it is fitted with a accessory that can be fixed with this installer that can push the nail inside the ground. So you can see this nail are being pushed to the ground. So for example, in this case, 20 feet, that's about 6 meters. So I told you before, in America, in the US, they are still using feet, right? So that's why in this magazine dated 2016, 20 feet long, 1.5 inches. That is about 25 plus 12, about 40 mm diameter. Nails are installed in a single shot using compressed air cannon, compressed air. We are using air nailer for our wood, timber product or furniture. So they are using similar concept, air pressure cannon to push this nail into the ground. This is some kind of what we call innovation that we are trying to achieve here. We are supposed to come up with all this innovation as a School of Housing, Building and Planning, especially those of you who are in the technology class. See, the same machine are using air pressure to push the nail into the ground. Okay, this is in Malaysia. In this case, we are using what we call the slope that has been disturbed need to be reinforced, need to be stabilized. In this case, we are using what we call shotcrete. Those of you who have been to Thailand through the third immigration station, which is in Durian Burong, will probably pass through this area. This is originally, this whole thing is a hill. somehow this road pass through the hill. You need to cut them, and then I'm sure this material has been cut, can be used somewhere elsewhere, can be used as fill material. That's one of the strategy to choose our route or road alignment, so that we can have a material from one place to the other required place or material. So in this case, you can see this is very steep, right? You let it in without doing anything. Now, definitely okay, it is safe, but we don't know after how many years it will collapse. In this case, they are using shotcrete like this, plus meshes. For example, these people are installing mesh on the slope before they spray shotcrete like that, right? Spray concrete. Shot, S-H-O-T, right? Shot. Kalau that's American, shotcrete. If you go to UK, they call it gunite, G-U-N-I-T-E, gunite. So you can see this American and European, they use slightly different terms. The same thing, gun, another shot. So shotcrete, gunite, same thing. You can see how steep it can be. See, this is the finished part. In this case, the shotcrete is being carried out top down from the above. The first stage, when you start excavation, you will have a shotcrete placed on this one. And as you go down, you place more shotcrete. So this is the lowest level. So this is the last shotcrete slope. You cannot cut everything first and start providing shotcrete. Something will be falling onto your head. So you have to start from top. We call it top down slope or reinforcement. A slightly less steep slope, you may be able to use slightly different approach or more green approach like this. You can have place what we call it a plant or grass on the slope, but before that, definitely you need to have certain layer of material that can hold the seed of the grass. If you can do that, then of course you can have a better slope like this, right? That is a greener slope. I think you have seen this before in our first lightweight geomaterial, right? So again, I will skip this one. Kan kita dah ni kan, lightweight geomaterial. When we had material in road construction, right? Okay. Lightweight geomaterial is another approach on how, instead of improving the soil, we tried not to impose the soil with additional load. So that's why lightweight. We are trying to use lightweight geomaterial that can either what do you call it, equalize the amount of loading, the existing loading on the ground with the proposed one. So we remove some soil, we put lightweight material, and then plus the vehicle weight, it will be still the same to the soil like it was before. So that's why lightweight material. So we replace the soil with the lighter material, and then plus the vehicle loading, the total amount of force on the soil will be still the same. So we won't cause any trouble to the existing soil. So that's how lightweight geomaterial is providing the solution. I think I've shown you this one before. Alright, so that's how it's done. For example, see, we have removed the soil here and replaced with a geo block or polystyrene block. This one is a lot more along the road, so there will be less pressure on the existing soil. I think I've shown you this. So there are various advantages if you are using the lightweight material. It will reduce construction period. It will reduce maintenance work. Because lightweight embankment is you bring this whole block of EPS. You don't have to compact. You don't have to. And you can bring so many of them at one time rather than bringing one lorry of soil each time, and then you can place them quickly because it's lighter. So one person can carry the whole block. So that is a period. You reduce construction period. Definitely you reduce maintenance work because there will be no settlement, right? That's my that's my primitive way of doing some what do you call it. Basically, what I'm trying to show you is that when there is a soil settlement approaching a bridge, your car will start jumping up and down before and after the bridge because of this settlement. So the lightweight geomaterial can give that solution. Something like that. Right? So before the bridge, this is a bridge. Right? So you will have that, then there will be no settlement because there will be no additional load on the soil before the bridge. The bridge itself will not settle because it's sitting on a pile. So that's how it works. So just geoform block at bridge approach, like we have in Second Penang Bridge. After it was completed, there was a lot of legal issues because of the road user are claiming that their vehicle are damaged because of this thing. You know, on the other side of the Second Penang Bridge, not on this side, in the mainland side of Penang Bridge. Now, in Penang Bridge, we use the same thing like this one, but this is not Penang Bridge. We are installing this block before. If you're coming from the mainland to Penang, below the road, just before the bridge, there are blocks like this. So now there is no more. I've been using this for the last 10 years, after they install that, I have no issue with bumpy riding. So lightweight geomaterial, again, it can reduce vertical and horizontal load. It reduces horizontal load and also vertical loading on the ground. Skip that. Even a retaining wall, it can reduce the pressure on the wall by almost half, right? Almost half. That's just to show you that. Another type of possible lightweight material is foam concrete and shredded tire, rubber. This can also be used and apply the same way we use the EPS block. But they are the way we install them will be slightly different. But the application is the same. It can be what you call embankment. It can be behind the retaining wall just now, or behind bridge abutment. It can be on the hill slope, so that you have less loading on the slope. It will minimize the earthwork operation because it's lighter. And it can also, some lightweight material that has got porous opening inside it will also allow what we call water behind the retaining wall to move away quickly from the wall. Right? You can remove the water quickly. Then there will be less pressure on the wall, so you are safe to be here. Right? Only thing about rubberized material, you may be interested to use rubberized material, especially waste material from tire. It has got some limitation, because if it deflects too much, it will cause, it will further aggravate the situation. If it doesn't deflect at all, it gives no meaning. So the concept is to create what we call active state, especially behind retaining wall. So you want to make sure the displacement or the deflection it match the need for the active state, and also it doesn't displace too much that can cause failure to can promote failure instead of strengthening the situation. So of course, if you're talking about shredded tire, you need, this whole tire need to be shredded and produced into block. Compared to EPS, you can produce them in factory. You can tell the factory whatever density that you need. But of course, even shredded tire, you can do the same. You can have different density. But if you're talking about a lot lighter density, you need to use the expanded polystyrene block. So I mentioned before, this is the mechanics of rubberized material, especially recycled rubber, like shredded tire. You need to control the thickness or the stiffness. So you want them to be, you need to use a correct thickness and correct stiffness so that they can perform at an optimum level. Otherwise, it may create issues like, later on I'll tell you the issues. So these are the two things you need to remember. If you are using rubber material in highway construction, remember, because highway deal with dynamic load. When vehicle move, it will create vibration. Rubber, when you expose to vibration, it may vibrate more. So you need to control the characteristic of the rubber must be correct. But it can be easily installed, just like EPS block. You can place them behind the wall like that. So that will prevent this area to settle, that prevent differential settlement. This is the, for example, this is a bridge or culvert or retaining wall. So that this lighter material will prevent the soil below to settle, right? Then we don't want the gap between this place and this bridge here, which will not settle because it is sitting on a pipe. So that's how we place them behind a wall of bridge abutment. So this is the rubber material, in this case tire, right? It can reduce the load or impact. For example, without the tire, this is the amount of load, right? With the tire, the impact will be less, which is good in the first glance. But once they are introduced to vibration or repeated load or from vehicle or even earthquake, it gives you vibration, this will happen. Without the rubber, with the rubber. Now when there is a vibration load, instead of calm down the loading, it will amplify the loading. So that is the limit, the issue that need to be addressed if we are going to use rubber material within a road structure. Okay. Of course, now it's a foam concrete, right? Foam concrete. Again, so this last few slides is about trying to reduce weight on the road. Foam concrete will do the same thing. This is a foam. Basically, you mix with concrete, and you can achieve different density from 400 to 1005. What is the density of soil? Anyone? Density of soil? Oh no, the density of concrete dulu. What is density of concrete? 24 lebih lah. 24 kilonewton per meter cube or 2,400 kilogram per meter cube or 2.4 ton per meter cube. You can see the foam concrete, it is from 2.4 only tinggal 4. So there is a lot of reduction in loading. 400 and 2,400. Imagine a lot less weight on the ground. Soil, siapa soil? Soil slightly less than concrete. It's about maximum about 2,000. Still higher, a lot higher than the foam concrete. So foam concrete is another lightweight material that can be used to ensure that we do not introduce big stress to the soil. So this is another option. But of course, when this is lighter with a less density, for example, it will not be very strong. Can be easily crushed. But then, of course, if it can be crushed, they may be useful in some other application. You don't use the low density for example, to support impact, for example, right? But then you never know, the low density is actually the one that will what they call it, save you. If you imagine you hit your head on this concrete, right? It is very hard, 2,400. You hit your head on the polystyrene, nothing happened, right? So same thing, you hit your head in a 400 kilogram concrete, dia boleh, you tumbuk lah buat movie ke, siapa nak buat berlakon boleh lah kan, tumbuk masuk dalam. So that kind of, it may save you. So there are what they call it, everything has got their own advantage, strength and weaknesses. So you decide in your actual application. For example, if you want a stronger road structure, for example, probably use slightly higher density foam concrete. But if you want to come up with crash what? You see along the road, they are usually at the when you are trying between two lane or when you exit the highway or you exit certain road, there is a certain what they call it impact absorber structure that can collapse. When you hit it, it will collapse. So that will reduce your impact. Same thing with the foam concrete, because it can crush, it can also absorb your impact. But so far, there's no product like that yet in the market. Maybe you can think of it, right? Siapa nak jadi kaya, boleh supply seluruh Malaysia. And this is on road. This is road project. Remember, we have a hilly slope. We are trying to create a platform. So this is a foam concrete, right? So it will impose less load on this slope. See, I'm standing on top of the slope here, very, very high. So we will create this very light concrete, lightweight like this. We have a slope here. This is lightweight. So this composite here, this soil composite here, this cement composite will have a very small impact on the slope stability because it's lighter. But if you use, for example, soil, 2,000 kilogram compared to 400 kilogram, that is a lot. 1/5, 1/4. Same thing here. So I will skip that. There's nothing to do with the road. And of course, this is a foam concrete concept. Cement plus sand plus foam. Plus, of course, water. Right? Very easy. That's the machine. This is a foam concrete. And all this lightweight material, including foam concrete, EPS, shredded rubber, and so on, can be applied in road construction in this way. Embankment, bridge abutment, lightweight behind retaining wall backfill, on the slope, and also it can be foundation, right? Lightweight geomaterial foundation. So that is all for today.